This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your host, Radio Joe Hughes, and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 686, and this week we welcome Bob Blochinger, Mickey Lee, and Dr. Ralph Moon for the Moisture Mob Flooring Panel Grand Finale. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget, after the show at afterthoughts/IAQradio.com, you can continue the discussion, sponsored by First OnSite. Our marquee sponsor is First OnSite at firstonsite.com. Our association sponsors are the American Conference of Governmental Industrial Hygienists, ACGIH.org, the American Industrial Hygiene Association, AIHA.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to Vic Cafaro, Chesterfield, Virginia, who was first to identify Rocky and Blowout as the other two movies in which the ship Mashulu, which transports young Vito Andolini to New York City, and The Godfather also appears. The IQ Radio Trivia question for today, January 13, 2023, has been sponsored by TSI Inc., an industry leader in precision instrumentation for monitoring of indoor air. Learn how to expand your IAQ investigations at tsi.com. Here's today's IAQ trivia question. Which character in Godfather 1 was given the name Leonardo Passifaro at birth? Back to you, Joe.
All right. Bob Blochinger was raised in New York City, working in the family construction business. He began his career in the flooring industry in 1970, offering carpet cleaning and installation while specializing in water and fire damage restoration. He later expanded into the retail department store sector, providing installation of floor covering sales. And during the 90s, his company started to service the architectural and interior design trade with high-end floor covering product sales and installation. He currently works as an expert witness, inspector, and investigator for law firms, condominium associations, and flooring manufacturers.
Mickey Lee is currently a private consultant, providing consulting, training, research, and writing services in the fields of property damage, restoration, psychrometrics, drawing science, mold remediation, and structural drawing after water intrusions. Mickey Lee retired from the Munters Corporation U.S. branch in 2011 after serving there in various roles for over 20 years.
And Dr. Ralph Moon is a building scientist with more than 42 years of consulting experience in the areas of duration of loss studies, material testing, risk assessment, project management, industrial hygiene, and indoor air quality assessment. Dr. Moon has published over 60 peer-reviewed papers and 40 technical articles and papers, and is a frequent expert witness on insurance-related claims and projects. Gentlemen, welcome to the show. Welcome back, I should say. Great to have you all back on this week. Let's start with Bob Blochinger. Bob, after last week's show, there was a series of emails going on between the participants on the show and some of the moisture mob here. And I think you made some really good points in those emails. I wonder if you could kind of summarize what your thoughts were after last week's show.
All right. I've always considered myself a field guy, not a chemist. And the how the concrete is made up that's for the consideration of others. But when we go in as a flooring installer, there's a lot of information we just don't know. And they try to blame us for any failures, or we should have known better, is the comment. And when we point out that the slab is not ready due to whatever testing we did, they say, well, we'll find somebody else if you don't want to do it. These are just negative comments from owners and contractors. But the bottom line is that the general contractor or owner, it's his responsibility to turn over a slab that is worthy of us working. A slab that has a surface which is irregular, dirty, soiled, full of debris, that's something that we can take care of as an installer. But the chemical makeup and the moisture emission of a slab is something that is beyond the scope of any typical installer. And I was on the side of not blaming the installer for everything, because he just doesn't know, because he didn't bring along his chemist, his attorney, and that's not up to us to do that. So there's a lot of science involved, which is beyond the scope of a everyday flooring installer, no matter what he's putting down.
Yeah, it's got to be a tough position for these guys. Like, it's a big job. They want that project, and they get there and they find that maybe, how many of these guys actually are out there measuring moisture content in the concrete before they start the project, Bob?
Probably 10%.
Wow.
And they use meters that they find in a retail store, which are not of the caliber that we require, such as myself. I have probably 3 meters, each one costing at least $1,000. And when you get them at Granger or one of the other retail outlets, you might spend $100. Well, there's no comparison. Ours is professional level, much better information. The other one, and besides the fact, most guys don't understand that this meter, no matter which one you have, is an indicator of a problem. The next step is to go to the ASTM 710 instructions, which tell you to do a 2170 or 1869 moisture test, which will tell you exactly what's going on within the slab. These meters, these impedance meters, they fail to realize they're indicators of a problem.
Interesting. So what, I kind of, there's kind of a disconnect there. 10% of these guys are even bothering to check for moisture. I guess in that case, I'm a little concerned. Maybe they do have some liability.
They do, in the respect that they accepted the slab as it is, which means whatever slab you go, or whatever substrate you're going to put a flooring onto, whether it's adhesive or whatever method you're going to use, once you touch that slab with a trowel of adhesive, you just bought it the way it is. And that's where their liability comes in. If they didn't do the proper testing and say, okay, we have elevated RH, now you give that to the owner, GC, you got to do something. You got to fix this before I can start doing something. Currently, I'm working on a 60,000 square foot retail store, 3 stories. We did moisture testing, and we have 3 different floors. One is on on grade, and part of it has a crawl space underneath it for whatever reason. These buildings were built in Miami Beach back in the 50s. Well, they're now mulling over how much money do we have to spend to make the concrete slab available to our glue down carpets and double stick installations, and what quality of adhesive do we have to have? And then what about the elevated pH that's sitting around 12, 13 when it should be 9? And most adhesives only go to 10. I think there's one that may go to 11. So there's various chemical aspects of floor covering that the installer should know or should research, maybe get an idea, but at the same time, he has to be able to stand up and say, look, this is not ready. Such as electrician, plumber, their word is accepted because they consider themselves to be trained, and everybody respects their trade because for whatever reason. But I've been saying for years, as a flooring guy, my work is just walked on. So there's little respect for what we do. And other people control our pricing, not us. So
interesting, Bob.
I could talk for hours on this.
I'll bet. I thought people should definitely check out the show we did with you. It's actually the first one we did with you, and it was excellent. We'll put the link up to it because you go over a lot of these issues in a great bit of detail. Mickey Lee, let's have you jump in here real quick before we go to Dr. Moon and his recent research on floor coverings and their effect from moisture. But Mickey, I wonder if you have any comments from the first show. Concrete moisture. I know most of the time you're probably dealing with concrete that got wet after the fact, not started out wet. But I'm wondering if you have any comments on the first show.
Several thoughts, Joe, and I'm totally with Bob on this. The people, because I come in after the intrusion, way after, and that concrete may have been there for 5 years, 10 years, 30 years, 50 years. So it's not new construction 99% of the time that I go on it. But I find that restorers who are tasked with drying the building often have exactly the same issues that Bob just mentioned. They don't use a decent meter. Even if they did use a decent meter, usually it's going to be the wrong meter. And then in a lot of cases, they don't know how to use it. Or they think that every meter is basically the same. You just hit the button, turn it on, and then you push it down on top of you press it to the concrete. And that's about the extent of a lot of it. And so I find that, in my classes, I teach them on proper use of different meters. And I also tell them, make sure that you've read the instructions. Because if you're on scale 1 and you should be on scale 2 and you're on scale 3 or whatever, you're not going to get any kind of a valid reading that's going to tell you anything. The other thing that I tell restorers, I say, look, you take readings and you do moisture mapping for your own purposes. But unless you are the flooring installer, you don't want to warrant that floor. And so I don't want to take that monkey on my back. So what I do is I find out, there's a lot of questions that I have, and maybe we can talk that through a little bit later as far as what I'm going to ask restore. But then I said, the last thing is you take readings for your own purposes. And at whatever point you think that it is dry, that it is, quote, back to what your drying goal is that you set, then you can go to your customer and say, Mr. Customer, I think you're ready to take your tests. Now, see the nuance of that. I didn't say, I think you're ready to put your floor in. I'm not saying that. I didn't tell you that. I think you're ready for your flooring installer to take their test. And so that way, and also I encourage you to use someone who understands the ASTM standards and who will do their testing according to the ASTM standard, whether it be the 1869, 2170, 2659, which is the one that I prefer, is the non-destructive testing. But I'm going to do it with a meter that I think is calibrated and is designed for that material, for that concrete. So that's kind of my I don't know what the instruction, but that's my information that I give to the restorers that I deal with. Now, most of what I'm dealing with, by the way, is not residential. My experience, my entire experience is in the commercial field, and in many cases on commercial losses, it's going to be a glue down commercial grade carpet or something of that nature that is being put on, or it may just be some type of an epoxy coating or some type of a coating on the concrete. So anyway, that's kind of where where I'm coming from.
Well, let's get Dr. Ralph Moon on here. You recently had a research project that was published, I believe, in the CIRI Journal, Cleaning Industry Research Institute Journal. And it was on, let me get my proper notes so I get the name right here, Ralph. Wood flooring, recognizing water damage, also with Nolan Wells and Donald Gehring. I thought the research is actually something we could do a whole show on, but maybe at least we could get people to understand a little bit about what real world scenario were you trying to kind of replicate there or simulate during that particular research, Ralph?
So we were curious about two common scenarios. Our work is predominantly with insurance companies, where we're asked to go in after water loss and figure out the cause, origin, and duration. And many times we go to a residential home and we'd ask the homeowner, did you ever notice you had a leak? And they had some type of a wood flooring material. It could have been solid, laminate, engineered, or balsam, or I'm sorry, bamboo. And we'd ask them, did you ever see anything? And they would say no. So we were curious in our first experiment that if you just had a wet foundation in which you had applied some wood flooring, when would you finally be able to see something was wrong with the flooring? And this is common for irrigation, when people irrigate the sides of their home and water is absorbed by the concrete foundation, or you have a very incipient leak that you don't really notice much, but it tends to move by capillary action throughout the entire foundation. So the first experiment was to look at a variety of wood materials and see how they responded over about a 4-month period when the foundation was damp, but there was no liquid water. And that's important because I don't think that's an uncommon scenario. So what we found is that the materials, the solid, the laminate, the engineered, and the bamboo perform precisely the same way as those materials would when exposed to moisture anyway. And that is that with just a damp floor, the solid wood material would tend to cup depending on how the wood was cut. And so materials that were cut with a rift sawn style, which is cut perpendicular to the annular rings of the wood and maintains its integrity, and it's also expensive too, because there's a little more waste, that performed very well despite the fact that it was wet on the bottom. It did not cut. The other forms did, especially the planer cut wood. And you can tell that when you look at the plank of wood and you'll see the annular rings is kind of a oval shape. That will distort quite quickly when it's exposed to water, with the underside swelling typically when that gets wet. Laminate, remarkably good. The engineered, remarkably good. And the bamboo as well. And for the most part, I think that the first question we had was, can you tell when it gets wet? And the answer is not really. Not unless you have solid that's cut in just a straight manner. But the rift and the others were remarkably stable for weeks and months when that floor was damp. Now, as a consequence, there was microbial growth that was quite prolific. All of them supported growth after about 7 to 9 days, depending upon the surface area that contacts the concrete. So the first experiment was basically focused on, okay, so we have a very modest leak. Can you tell when it gets wet? Answer is not very easily, unless you have solid wood that's cut the way I described. But the laminate, the engineered, and the bamboo was really excellent. The bamboo showed some cracking and some surface mold after about 2 or 3 months, but the engineered and the laminate was really good. And even discoloration was quite slight. So the bottom line was that for homeowners, for restorers, for cleaning professionals, when they come across a water loss, you really can't expect them to identify a leak early in the game unless they bring a moisture meter or they have a chance to pull up the flooring, in which case they would see microbial growth. So that was the first thing that kind of surprised us, because we thought you'd see it earlier. The second experiment, and these lasted about 3 to 4 months, is we submerged the flooring in water, not immersed, submerged. So it was partially wet, about half of it, to simulate that nasty on vacation leak. When you have a leak from the toilet, the ice maker, you're gone for 2 or 3 weeks and the home floods. And we were curious, what does that look like? And should someone obviously recognize it? Well, in the briefest of terms, it got ugly quick. I mean, the extent of microbial growth, the surface discoloration, and some distortion, especially when the solid materials, happened pretty rapidly. Now, remarkably, when solid materials get all wet, I mean, about the same time, they don't really deflect too much. They don't really cup too much. And I was wrong in saying it deflected, but that was really unusual in the appearance. It looked bad. Now, the bamboo, the laminate, and the engineered, they also look bad. They didn't really distort too much. So their underlying competency is quite high. So for that reason, we thought this was helpful to give us a perspective, especially if you have a certain insurance claim. Is it reasonable for a homeowner to see the damage within 2 weeks or a period of time? And the answer is, unless they're really thinking about their floor, and is my floor wet? Honey, is the floor wet today? I don't know. Just check it out. Unless they're doing that, I would doubt that they would see it within 2, 3, 4, even 5 or 6 weeks, because it's just not visibly apparent. Now, there are some things that made perfect sense. Like, for example, when you walk on a laminate floor that's been wet, you notice that the edges kind of get worn. And you see that vinyl wearing off the butted ends of the flooring. Made perfect sense. Why? Because when it gets wet, those butted ends tend to swell more than the interior portions of the plank. So they stick up. And so when you walk on it and there's a wear pattern, you see that wearing on the butted ends. What should that tell you? You might have a leak. Something's probably caused that composite wood material to swell. So that was interesting thing to kind of confirm what we see in the field when we see those worn edges, and we've all seen it. Is that means that floor is gained some moisture.
Ralph, I have a quick 2 follow-ups. One was when it's submerged in water. You said it pretty quickly, I think was the term you used. How quickly? Are we talking hours or days before the microbial growth started to become visible?
Yeah, within days. I mean, anytime, in all of our work with wood materials, once you add water, the liquid water in particular, you get a response within 2 or 3 days where you start to see microbial growth. It's not mysterious at all. I think the only time that it takes longer is when you're dealing with this elevated humidity. But with liquid water, there's a critical response of just a couple of days and you start to see growth. As I said, we did this twice, and with the immersion, that it was pretty rapid on all types of flooring where you'd see the microbial growth. So that's not terribly mysterious. When the floor, the concrete just is damp, that takes longer and may not be visible unless you pull it up for months.
All right, now you led right into my second question beautifully, Ralph. It's like we planned this, but we didn't. Damp. Can you define what was damp for the experiment, for the research?
Sure. So in this experiment, which I have to thank Nolan Wells for doing the base, that's for sure. We had a very flat 2 by 3 foot slab in which we added water around the perimeter, kind of like a moat. So water was absorbed, but not poured on the slab. And so it was damp to the touch. And now if you use a moisture meter, you'd get excessive moisture, no doubt. But there's no visible water. And we made sure that it was stayed about maybe 1/8 of an inch below the top of the slab, very, very flat. So when we placed the wood on the samples of wood on the concrete, it was damp to the touch, but not wet. That's how we define that.
Now, I noticed that, like all good researchers, you were very careful when you talked about how people would recognize the damage in the moisture damaged wood that had been exposed to dampness. And then again, also in the moisture damaged products that were, immersed in water. One of the things I don't think your study really looked at real closely, but you did mention in the paper, was there was a tremendous odor as well with, I don't remember which it was, but I would imagine one of the things you would recommend is that we look more closely at when that odor occurs to help people in determining if there was a water damage.
Yeah, and the reason we don't use olfactory evidence, it's just that I've been tagged in depositions that unless I have a qualified nose, and there are people that have like certified noses for a variety of chemicals, you can't testify an odor, so I don't. But the point is that usually within about 2 to 5 days, you get a fairly pleasant wet wood smell. That's true for really all the wood materials we work with. It's not unpleasant, it's a smell of wet wood, no problem. But after about 2 to 3 weeks, it begins to mature to something much more obnoxious. And there's also an interesting period between about days 30 to 60 where it increases in odor, and after 60 it becomes more earth-like, like the smell of soil, an earthy smell. And after day 120, usually there's some exhaustion in all the available sugars and carbohydrates the fungi consume, and then it actually diminishes a little bit. But the point is that there is an odor character or a signature that indicates initial wetness, that's like wet wood smell, and then it advances to more obnoxious odors between 30 and 65 days or so.
Very interesting. Cliff, if you wanted to jump in.
Yeah, actually, I wanted to ask Ralph a couple of questions. When you were doing the studies, Ralph, particularly on the one that you submerged, it would seem to me that you can have a couple things going on there. Particularly underwater, you might have bacterial growth. You might have the beginning of fermentation because you had some sugars and so on and so forth. And then I guess where it's the wood is just damp, there you're going to have fungal growth. So I'm just not sure whether I'm not sure what all the odors are related to, certain things. I mean, even cardboard, when it gets wet, it has a particular odor. And, like you talked about wet wood having an odor. I just wondered whether you thought that, there might be some bacterial contribution or fermentation, particularly when there's a lot of water for a long period of time.
Well, Cliff, as you know, you're absolutely right. It's complex, because this wasn't done under sterile conditions, and we didn't use like distilled water. We used just tap water from the city of Tampa. But when you add wood to water and allow it to sit in a circulating atmosphere, both fungi and bacteria grow. Now, we both understand that when you submerge wood, and I've seen this in old 1880s ships that sunk in Lake Michigan, they don't decay because of the absence of oxygen. But when you submerge it and allow oxygen to combine, you have a prolific microbial grouping of bacteria and fungi that's complex, and it wasn't our example. But the point was that if you're dealing with a long-term, high-volume leak in a home, you can expect significant deterioration of the flooring material and very advanced microbial growth, within a week or two of the initial loss. And oftentimes I'm asked to date these things, how long they last. And for the submerged situation, after about a month or two, you can't distinguish that easily from 3, 4, 5 months, because it just gets very advanced and you can't separate those two. But if you had something early in the game, like just a couple of days, and there was some submergence of the wood material, that should be relatively modest in the damage. Now, that's all I can say really to distinguish long-term from short-term. But nonetheless, it's much more advanced with that submergence because of the abundant oxygen and moisture.
Thanks.
Ralph, I'm curious, after that research, what would be your preferred flooring for its resilience to water damage?
Well, if you got a good pocketbook, the wood that was cut with straight, that expensive cut, would be preferable because it didn't cop. Let me see if I can find that name. But the other would be simply laminate. I'm sorry, not laminate. Engineered wood. Engineered wood is like plywood, and if you get marine grade or exterior grade plywood, when it gets wet, its consequences are fairly modest. Same thing is true with a good engineered flooring system. And of course, if you go to the Home Depot and Lowe's as we have, there are a wide variety of quote laminated floorings. Engineered floorings that have a variety of materials in them. You just want to make sure you don't get any composite woods in them, because they will swell in response to moisture. But if it's like a normal laminate layers of wood of various thicknesses, then I think that's best. And what was interesting is, despite the fact that they were wetted for, almost 4 months, there was no torque, no cupping. They were very nicely flat. And the surface layer, as I said, didn't distort visibly when they're exposed to moisture. So I'd go with engineered flooring, and probably after that, probably the laminate, only because it didn't really change too much. And like a product like Pergo has that little foam beneath it, and the foam tended to keep it more protected from that wet concrete surface than those that were right on the concrete. Now, there would obviously be an adhesive between that and the flooring normally. We didn't have adhesives. We had it right on the concrete. But as far as competency, the Pergo-like products did quite well. And the bamboos did very well too. And of course, they're not a wood, they're a grass. But nonetheless, the general performance for all of them was fairly good for a couple of months. The only one that really changed right away was the solid wood that was cut with the plain cutting of the log that did not intercept all the annual rings vertically.
And Ralph, I noticed also that you also looked at plywood and OSB. Is that accurate?
Oh yeah, we looked at that for about a year for wetting for constant moisture and repeated. And the nice thing about that story is the performance of the plywood materials, exterior grade, interior grade, generally was comparable to that of the engineered wood floor. Is that there was some slight distortion in the products used for floor and wall and roof sheathing, but generally their performance was actually quite good. So once it was dried, even after a year of wetting, that exterior grade plywood was really quite competent. I can't say that for the interior grade materials, but the exterior was very good. So yeah, and then the OSB, did you mention OSB, Joe?
Yes.
Basically a composite wood. The composite woods don't do well. And that's a component within the Forest Products Laboratory. They've been wrestling with since the 50s. How do we get these composite wood products, much like we have now with the flooring with the same types of materials in them, to behave better when exposed to moisture? And it's a struggle because there's an inherent capacity of the wood to absorb moisture they can't really absorb, they can't avoid.
And I'm looking at, I'm going to ask this for a reason. I want to come back to Bob after halftime on this luxury vinyl tile. I don't see that on the list here. Ralph, was that part of your research?
Well, I think I would probably relate that to the denser form of the flooring than the lead. It depends on the pressure you apply to it, but luxury implies something to do with the surface appearance. I'm not sure if it does as much to if it's commercial grade or residential grade. So it must have something to do with the appearance of the vinyl to look more attractive.
Okay. Let's go to halftime, John. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Our association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry. IICRC.org. Industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back with Bob Blochinger, Mickey Lee, and Ralph Moon. Bob, I want to go back to your first show we did with you. And on that show, in Cliff's blog, it said the luxury vinyl tile is the bane of the industry because we don't know what it will do once it's on the floor. We have no control over installation, workmanship, training, and we don't know where it's going to be disposed of when replacement time comes. I wonder if there's anything, I think that was about a year and a half, 2 years ago. Anything new on this? It's a pretty popular product. And I would imagine the manufacturers know there were issues. Are they doing anything to help solve these problems?
Yeah. A while back, they came out with new instructions, which is one of the things that installers tend to fail to read, instructions on installation. And now they want you to put a viscreen type moisture barrier on the concrete slab before you put the floor down with a 6 mil or better quality. This is to prevent any moisture from the concrete coming up. Then you do the click system. They don't ask for a specific moisture test anymore because they say that these floors are waterproof. But yet, why do you need moisture remediation before you put the floor down? So it's like an oxymoron. As far as the product itself, it has improved. They've gotten better with moisture absorption by the core. This morning, I just looked at a job with an SPC, which is a stone polymer core. And the problem wasn't any moisture, it was constriction in movement, which means that they didn't leave enough expansion space. So you've got a couple of variables out there, and it's all because of, to me personally, lack of formal training, which means the person went to a structure, a classroom, not online, and had a teacher, and then he had to pass a test. That to me is certification. And these online and YouTubes just don't make it for me as a former installer. So as far as getting better, yes, the LVTs are getting better, much better than they were even 6 months ago, due to the manufacturer's research and whatnot. It's just that you have to, as the expression says, buyer beware. If you're going to pay a 99 cent per square foot flooring, that's exactly what you get. If you're going to pay a $3, $4, $5 a square foot flooring, you get a much better product. Just like anything else, you get what you pay for.
Yeah, that's a great point, Rob.
But they still haven't resolved, what do we do when we replace it? It's just going to the land dump. It's not a recyclable product. There's no recycle program that I know of for LVT. And it is being used commercially more and more. I see it in hotel rooms, in hotels, and it's a great product for maintenance and quick installation, but it still has inherent problems because it is, to me, I have this phrase I use, it's a chemical sandwich destined to fail.
Interesting, very interesting. All right, let's go back to Mickey. Mickey, we've talked a lot about moisture coming from below and from the sides on concrete slabs. I'm wondering, you most of the time are called in, I think, when there's a flood of some type, a broken pipe, etc. And I'm curious, when you're drying on these projects, does moisture from below ever affect the ability to dry out a moisture issue that came from above?
Joe, in most cases, we are not seeing moisture coming up through the concrete. Okay, most of the time it's going to be either through a broken water line, an overflow, a roof leak, a water intrusion coming in like a flood. So generally, we're going to be drying out the structure And while we're drying out the structure, we're going to be drying out the carpet, or if it's something like engineered flooring or laminate flooring or something else that is damaged and saturated, that's probably going to be a rip out. That's probably going to be a replacement. So we don't see a lot of water coming up from underneath a slab or from underneath on most water damages.
And Bob, I'm wondering, in your business, you do a lot of expert witness stuff. You do a lot of inspection. How often do you find moisture wicking up from below is a problem on these projects?
Quite often. Here in South Florida, when we have our HVAC units operating the AC, I'm finding that some of these homes are 60% or better in RH value. And as flooring guys, we like to see 45 to 55%. And, moisture goes to cold. So any moisture in the concrete is drawn up into the house, which is, I'm going to say 74 degrees and 55% humidity, versus outside we have 90% humidity and the temperature is 85 degrees. So you have that equilibrium fight. All the doors and windows and roofs, everything is sealed for exterior moisture coming in, but the concrete has moisture in it forever. So therefore, that's where it's drawn from. And I've had many instances where I was allowed to do destructive testing, whether it's a glue down wood, laminate, engineered solid wood floor, and of late vinyl flooring. And I lift up that first piece and the smell of mildew basically smacks you in the face, to the point that I've had customers scream and run out the door because of the the mold and mildew and all that stuff. So for South Florida, it's a problem. And it doesn't
Ralph,
matter.
Go ahead. I'm sorry, Bob.
It doesn't matter if you're an on-grade slab or you're 20 stories in the air. It doesn't matter, because it's all about the ambient conditions and the concrete slab emitting its moisture.
Ralph, I'm wondering, in all of your time doing your expert witness work and looking at projects, have you run into the people having a difficult time drying out a slab because there's moisture below? You get a broken water line or whatever the case may be, it floods your slab. You have problems with people that. Go ahead.
Early in the game, 15 years ago, when we were involved with water damage, that was probably one of the most torturous events to try to monitor. Was a wet concrete slab on grade that seemed to take, they had equipment in place for months, and the rate at which they were diminishing the moisture was just declining so slowly. So it's a very difficult task, because concrete inherently wants to absorb moisture. That's the nature of its chemistry. But I found that very, very hard. I want to comment on Robert's statement about what we call vapor drive. That is water vapor moving from high concentration to low. And in Florida in particular, any home with a crawl space, when the crawl space is wet and or humid and cool and warm, and the interior space is warm and dry, then you have movement of water vapor through the flooring, resulting in cupping and all the things he mentioned, the mold growth and so forth. But this is particularly common in South Florida, because many people like to keep their homes at 72, 70 degrees even. And if the outside's 85, 80, high humidity, that floor will die if you have a crawl space, unless you have some way of protecting the vapor movement. But very common problem throughout the state if you have a crawl space situation with vapor drive and wood flooring.
I want to go back to Bob for a minute here. Bob, before we go to our roundup and bring in Andrew, and I'm not sure, I think we've got a few others. Pete, of course, will be back, and I think we've got Robert back from our first show. But before we go there, Bob, can you give us a quick status update on the standards that you've been working on with IICRC? What's coming out next? What's getting revised?
Well, as I mentioned earlier, the standards S800, which is the carpet textile standard for inspection, that was just put out to peer review today. So in about 6 weeks or so, we're going to see what everybody has to say about it, and I guess do some corrections and whatnot. Then
And that's an IICRC standard?
IICRC standard S800
Okay.
textile flooring inspection procedures. I'm a guest on the S2, was it the 230 and the BMI standard for which is building moisture, coming out of Montreal with Gabriel. They're both these guys are working on those, and those committees are probably some of the best in the country as far as their level of experience and education. They should be coming out sometime this year, if I'm not mistaken. Other than that, those are the only ones I'm involved in.
Okay, so that the second one you talked about, that's on how to measure moisture in buildings, moisture related issues in buildings. Is that accurate?
Yeah, it's identifying and measuring.
Seems like that's something we should have had before.
Yeah, it's well past due, but these standards are all made by volunteers, so it takes time.
Great point, Bob. Let's go to the roundup, John. All right, the roundup. Hey, I just want to thank Madison IAQ again. And I tell you, we were talking before the show about the Thermostor's ventilating, dehumidifying, filtering unit. I love that thing. More and more people should be using those. They're just tremendous products. But anyway, let's go over. Did Bob Higgins join us? I haven't been able to watch the chat. Pete, let me know what's going on here.
Hey, so let me tell you before you call on Andrew. So I don't see Bob on here yet. Maybe he may call in. But what happened is Roland is on here. And, on the last show, William said that Roland has some good comments. Now, Roland is on a cell phone, and he was at 408 number. I verified it, but then it looks like he maybe came in or out. So, John Faith, if you see Roland call in on that 408 number, we should try to call him back in. He's probably driving, and maybe he had something come up, so he had to go off. But that's the only thing I see on the chat log. So, back to you, Joe.
All right, well, let's bring in Andrew here and see, Andrew, what kind of comments you have after this one. I know this is a show that's got to be really interesting for you. Andrew Reinhardt from the Tramex Group. Andrew, do we have you?
Thank you, Joe. Yeah, if you can hear me.
Yes, sir.
Great. I really enjoyed listening to that. There's not a huge amount for me to add at all. I liked hearing what Ralph was saying about the testing they were doing. And I personally, it's obviously it's a personal choice, but when it comes to flooring, I think natural products are so much better for walking on and for long-term health of the occupants than actually walking on plastic. So it's not just the fact that it goes to landfill, which is a really important point, but having these sort of plastic floors is not great for health. But when you've got hygroscopic materials such as wood or even bamboo or other things, then the amount of vapor within the concrete becomes important. And especially when the top of them are coated so that they reduce the vapor transmission through the floor, then the vapor builds up within them. But a lot of wood products will allow vapor to come out the top of the product as well, so it doesn't build up to such a degree. A lot of the discussion around moisture testing actually comes from, this is another point, it comes from the resilient flooring industry. So, with solid wood, there's a lot of consideration about vapor pressure as well as moisture pressure. And if you don't mind, I'd like to say something on last week's discussion as well, because it came up. There seemed to be a discussion about not using vapor barriers or not using surface barriers to protect flooring, that they were unnecessary, like epoxy and other things. And it's my experience, and this is just my own personal view, is that they are over-specified for new concrete and they're not used enough for older concrete. So I think if the moisture testing is done correctly, there will be maybe less sealers used on new concrete, but a lot more used on older concrete. And I say that because with new concrete, the water is there, the construction of water is there, and it actually stops more moisture transmitting through it. But with older concrete, when you have empty, sort of the pore spaces or the capillary spaces are void, empty, then moisture can come up into that concrete and be absorbed up into that concrete, even during heavy rain, or you can have the vapor differential causing issues. So when it's tested properly, especially for old concrete, the sealers can help the building as well as the floor. So they're actually, I feel like they should be used a lot more with older concrete rather than newer concrete. Apart from that, it was a great discussion. There's so much to say, but I don't want to start a whole big discussion on moisture testing within concrete. But there's two things to consider. One is the adhesive and the other is the floor product. So with the adhesive, particularly, it's moisture near the surface that causes the issues, because the adhesive needs to be allowed to create the bond strength that it was designed to create. And so if there is no moisture near the surface, the adhesive can form a proper bond. But then when you have issues like smell issues or something that can develop over time, that needs to be considered, as well. So that's moisture coming up and building up over time. So I don't know, but it was a great discussion and I really appreciated it. So thank you.
I think the thing that really struck me was that we didn't talk as much about moisture, and this is something that Steve Brook talks about in some of his work, moisture coming from the sides, not necessarily from below a concrete slab, but coming in from the sides of a concrete slab, and that we have to protect from that more carefully. And I thought that was an important point. But Andrew, what I wanted to ask you real quick is, I've seen, I've been kind of affiliated with the water damage guys for, 20 years now. I don't do water damage restoration, but I do help evaluate projects. And I always used the concrete encounter, which I think was a Tramex product. And I was wondering, why is it so much more expensive to build a concrete meter, a good concrete meter, versus a multi-use meter?
Well, it's also the quantity of scale. If you're building meters for specialized markets, you're not building them on the same scale. They're not made mass produced. So there's a lot of different factors like that, and particularly calibration. There's a lot of work done on making sure the calibration is correct. But I know that I've seen stuff that's produced, electronic equipment that's produced, and if you knew the conditions that it was produced under, you just wouldn't buy it, where you can save money by not paying people and, treating them quite badly. But it's one of the issues we have in the world today. So, I was thinking about that myself recently. If somehow, Bob mentioned that 10% of the floors installed were using meters. If we could get that up to 80%, we could certainly do an awful lot in terms of how we produce, how big the runs of meters that we do, to bring the price down, So it's something that would be good to have a sort of an industry-wide discussion on how to do that.
Let me comment on a couple of things that Andrew said, since Andrew brought this up. So, hey, John Faith, while I got you, can you put a link in the chat log directly to Cliff's the Z-Man blog from last week? John, do that.
Yep.
So a bunch of you on this call were on there last week, but some of you were not. And if you haven't read the blog that went out, John will put a link in there. You want to go take a look at the blog. Now, the whole blog is great, but my point I'm going to make is scan all the way down to where the watchdog comments are, and then go down a little bit and see what Joe Steebrook responded to. And this lends to the point that Andrew just brought up. I had made some comments where I quoted Steebrook. And after a while, when I thought about it, I said, well, if I'm going to put Steebrook's name out there, we ought to have him vet the comment, because sometimes the watchdog, the puppy's so excited, he starts peeing all over the place. You can't stay on the paper, right? Now, Mickey, you're smiling because you can definitely relate to that. You know exactly what I'm talking about. So anyway, so Steebrook responded back, and his comments are in the final blog. Now, this is what Steebrook said. What brought this whole thing up was Higgins made a comment that plastic poly sheeting, or Bob Blochinger said Visqueen, which is just a brand name of a product. West Coast usually, I used to use the term Visqueen in the 80s and 90s when I lived in California. And basically, Higgins' viewpoint was it's worthless. It's worthless as a vapor barrier. And Seabrook had a little bit of a different viewpoint. The main thing I remember from Seabrook's teaching in the 90s, when Cliff and myself first started going and we saw him at the City Science Center, Philadelphia, he said the most important thing, if you're in an area where there's either high water levels or a lot of rain and you have a slab directly on soil, he said you need to have a capillary break. And his suggestion for the capillary break are stones. He said, like in the old days, they would put stones down, then they would build off of that. All right. I asked about pea gravel. He said in some cases they use pea gravel as a break, but obviously it's not as good as doing stones. Then what he said, that's what's actually going to stop is going to separate the moisture from getting directly in the concrete. Now he said in those analogies, he says he has suggested that they can put like a poly sheeting down. But what he suggested was, he says usually when they do it, he gets the installers, whoever's laying it, they put golf spikes on and they walk around and they put little holes in there, right? And then they pour it over like that. But he said, here's where the biggest issue is. And Joe, you brought this up, and Andrew made a comment. He said the biggest issue is when they put it down, they don't do the perimeters. They don't do the perimeters properly. So he says what happens is it may be fine in the basic field of the concrete, but he says the water pools around the end. He says then it kind of slips up over the side. It gets into the concrete, all right, and then it starts to travel through the surface of the concrete. So the analogy for this would be anyone who's in the construction and knows about building envelopes. One of Steve Brook's famous sayings, and he wrote a couple on all these things on his website. There's so many technical things for free you could download. But he says, if you want to save cash, flash. So if you build a building and you don't have proper flashing on the roof, around the windows, that's where you're going to get the moisture penetration, either from the wind-driven rain, seepage, whatever. So that's the analogy. When I had a talk with him last week before he put his comments over the blog, I said, so Joe, so what you're saying is that's the equivalent, if you want to save cash flash, is that if you're going to use the poly, you have to wrap it, you have to protect the perimeter when it's down, otherwise the moisture gets in. So, I mean, the biggest thing that I recall when I first listened to Joe talk, and he talked about how moisture gets into buildings, he said, you have to look at them in orders of magnitude. Now, from restoration and guys, they know the most important thing when you walk into a building is to get rid of the standing water. If you're going to dry the carpet in place, do a thorough extraction. If you do a lousy extraction, that means the rest of the moisture that's in those materials, you have to try to remove it through air movement, dehumidification, and temperature differentials. That's hard to do that. All right. Very hard. So he said the first thing they have to do is you have to have a roof on the building. You got to stop the rain from coming in. Then you got to deal with the perimeter of the building. You have to drain the rain on the plane. Okay. Then that water that goes around the back that gets sucked into the building through capillary action. After that, the two things are air movement and vapor diffusion. And people put a lot of effort and energy on those things, which are like least important to controlling the moisture and the physical bulk water in the building. Now, I remember in the early days with Munters had a lot of information, making recalls that they put out about controlling moisture in buildings. The air transport was important because it was based on the leakage, how often people open doors and windows, what kind of people were in the building. Was it a gymnasium where they're giving a lot of moisture off, or is it just a stable office? Those things were important. And if you were in a hot, humid climate, how you control that, like in supermarkets and things like that was a lot different than what you would do in a home that was in a different climate zone. This is what all these builders climate zone books are about, to understand that, how to control the moisture. So what I find in the restoration industry, and I can be critical of this, is sometimes the things of lesser importance, the training puts too much emphasis on it, and they forget in orders of magnitude there are things that are more important. That was something that resonated with me and Cliff years ago was orders of magnitude on the mechanisms for moisture getting in, and also the water activity issue. We're not going to get discussion, but that, when that was presented to us in the 90s, nobody knew what the heck water activity was. Now they start to talk more about it. It's the moisture that's at the surface of the materials that's important, and that's Higgins' big point with concrete. All the issues is whatever moisture is on the surface. It isn't all the stuff that's deep down. Now, Andrew knows, a lot of those meters are designed, different technology are designed to do a deeper reading. But at the end of the day, most of the problems was ever on the surface. Now, anyway, but that's the best I can recollect from my teaching from Steybrook. And be careful. I don't want to have to go back to vet anything. Cliff was writing like a maniac. So don't use Steybrook's name. Just say the watchdog went off on a rant. That'd be okay. But anyway, so Andrew, I hope that kind of reinforced what you were saying, is that these issues around the perimeter of the edges, and this is how the moisture gets in that gets unattended. So if you want to save cash, flash or wrap on the perimeter. Anyway, back to you, Joe.
Well, that's why when testing concrete, it's very important to do a moisture map on the surface of the concrete with a concrete meter if possible, and but any meter. And then the best thing about the in-depth readings, if we developed, and I'm not trying to plug it here or anything, but we developed a probe for testing the moisture deep within the concrete, and you can do an RH test deep within the concrete as well. And the whole purpose of that is to see that is the moisture coming up within the concrete, or is it coming down from the surface through dew point issues or something else in the building. And if you have moisture coming up, it's the difference between the moisture in depth and the moisture at the surface that should point you to putting down a sealer, rather than the actual amount of moisture necessarily, because with older concrete particularly, the construction water is gone. So if you use the same standard, so if you say, right, the RH has to be below 85, or the moisture has to be below 4.5 or 4%, whichever you're using, and then you go to a 30-year-old concrete and you've got readings up near 80, and you've got moisture 4 and around a bit more. If the equilibrium moisture content in that area is much lower, then you still got moisture problems. So you need to know what your EMC, or your equilibrium moisture content, is in your local area. It's easy in Ireland because it's all one climate, but in the United States, there's different climates. So if you're in Colorado versus Florida, you should be looking in older concrete in Colorado should be 2.5%. And in Florida, it could be 4%, so it's something you need to be testing regularly in your area to know what a dry concrete measures to. And the same with RH testing, like we've tested sometimes in Las Vegas at trade shows, and you get the moisture in the concrete's less than 2%, in older concrete. So if you got a concrete that was 3.5 or 4, then there's moisture coming into that from somewhere if it's old concrete. So sometimes having a number is not good for old concrete. What you want to know is if there is excess moisture, where is it coming from? Is it coming up from the bottom, or is it coming down from the top? It could be from an old leak, or it could be from dew point, or it could be from alkalinity in the surface. There's different reasons why you can have moisture in the top of the concrete.
Hey Joe,
go ahead, Pete.
One thing I want to throw out there before we sign off. I know Bob Blochinger had to leave, and Ralph went into depth, but I don't think Mickey's got equal time. And before we sign off, I think it would be remiss if we didn't give Mickey one of the elder statesmen in the moisture and the drying business, and one of the most highly regarded people in there. If he maybe says a couple of words that Cliff could put in the blog that are kind of, call them the Mickey pearls. If Mickey is going to give some advice or give some information based on your personal experience, Mickey, to the restoration remediation people, to the indoor air quality, the mold assessor testers, all that, what are a couple of Mickey's pearls that Cliff could basically put in a blog? I think Mickey has deserved the opportunity to get the last word, at least on that, before we close this show out. So, Mickey.
Well, Pete, I appreciate that. I don't know that I've earned the right to have the last word, of course, but basically I am coming from a practitioner standpoint, from actual drying out of buildings after they have gotten wet. And one of the things that I tell my students, and I've been preaching for many years on this, is don't step over dollar to get dimes. That means don't get a cheap meter. And I am not a fan of all of the convergence technology. to wrap everything into one. Hey, get you an infrared camera that's also a moisture meter, that is also a thermal hygrometer, that is also a can opener, and yada yada yada. It's stupid to think that you're going to be saving money. So get you a good meter that is valid on concrete. Get you a good meter that is a really good thermal hygrometer. Get you some good moisture meters, and don't feel like that you can go into any old building and just pull out your convergence meter and you can test the drywall, you can test the concrete, you can test the wood, and that's all you do. So don't do that. And so that would be one of them. And then secondly is I like to tell my guys, hey, it's dry when it's dry. So you determine what your dry standard is and set your drying goal, determine what your drying goal is, and then you dry to that point. Don't make promises. Hey, I'm going to have your building dry in 4 days, 6 days, 5 days. No, you need to let the building tell you when it's dry. So the only way that you can let a building talk to you is through good meters. So let the building tell you when it's dry. Don't overpromise, because if you're the last person that touches those materials, boy, it's going to come back on you. So I don't know, Pete, whether that's a Mickey-isms you were looking for.
Well, whatever it was that you had to say, Mickey, it wasn't the last word, but you need to I thought, fill in as part of the panel to get the last word in that area. And of course, a couple of the boys, Clayton and Josh, they're in there, giving a good old attaboy to Mickey. So I guess you at least resonate with a couple guys, and that's what's important.
Let me go to Cliff. I didn't get a chance to ask you any final thoughts or questions.
I'm good, Joe. Thanks.
And then I want to go to Ralph Moon. Dr. Ralph, final thoughts, anything you'd like to add?
Yeah, I think it's been a real cohesive show, kind of bring in meters and concrete issues, flooring, and so forth. But I think that my final point for the restoration contractors is to be sensitive about using the proper meters and being very curious about the condition of flooring that you're removing or examining for its potential damage with excessive moisture.
Ralph, always appreciated. Very interesting. What are you working on now, by the way? Any more research coming out, or are you trying to slow down a little bit, Ralph?
Well, I met with some colleagues, and then the two guys that work with here, Nierig and Wells, about a test procedure to evaluate the effect of corrosion of cleaning solvents on various metal components. And we'll see to what extent I'll be involved with that. But we spoke to some length yesterday about designing the experimental design.
Fantastic. All right. So this is Radio Joe Hughes saying thanks to this week's guests, Bob Blochinger, Mickey Lee, Dr. Ralph Moon. Always great talking to you guys. My co-host, the Z-Man, John, you got to have faith. Most importantly, our loyal audience and sponsors. Next week, we've got an interesting show with the CEO of GHP Group out in, I believe they're in Arkansas or over in that area, Dominique Arrieta. We've got Paul Grimm. He is their Director of Project Operations, and Ken Garza, their VP of Industrial Hygiene. They're doing some interesting stuff with respect to reactive versus proactive IAQ investigations. So looking forward to a great show with them next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.